sketch the graph of f of x equals radical negative x minus 3 plus 2. Okay, so what are the things that we notice about this particular function? Okay, first of all, we notice there's a radical, right? So this is based on the so-called radical function, radical x. Okay, so we should know what that graph looks like. Okay, so just radical x by itself. Okay, what is that the graph of? Okay, now we can make a table. Or once again, at this point, we should know what the graph looks like. It's going to be a little bit like a U, but it's half a U that's sideways, right? So 0, 0, 1, 1, 4, 2, 9, 3, something like that. Now it's a little bit curved, okay? So it's not exactly straight, okay, but it's a little bit of a curved line, okay? So it's a half a parabola that's sort of sideways, okay? So this is the graph of f of x is radical x. Okay? But then what is this the graph of, right? So we know a couple things, right? We know that this graph, right, should look similar to this guy, right? Should look similar, okay? But there are some transformations that are going on, okay? So we can make a table of values here and sort of, try to determine what we're going to get, okay? But then, once again, what you want to be able to do is use the transformations, right? We want to use the transformations to get the final graph, okay? So let's try this, right? Let's try plugging x equals 0 in here. And there's a problem with this, right? When you plug in x as 0, we get 0 minus 3, which is radical negative 3. Right? Well, wait a minute. Radical negative 3 does not exist. So when we plug in 0 here, okay, we don't get a y value. So 0 is not going to be in our domain. And notice, well, wait a minute. If I plug in 1, right, I get negative 1 minus 3, which is negative 4. Well, wait a minute. Radical negative 4 does not exist either. Okay. So then what can we conclude then? Well, let's try negative 3 then. Okay. The reason why I'm going to plug negative 3 is I know that that gives me a 0 inside the radical, right? Because we get negative of negative 3, which is positive 3, minus 3, which is 0, right? So when we plug in negative 3 into the function and work everything out, we actually get 2. So hopefully you realize here, yeah, I can start at negative 3, but I can't pick any values to the right of negative 3, right? I have to pick values to the left of it. So when you plug in negative 4, that becomes positive 4. 4 minus 3 is 1. 1 plus 2 gives me 3. Okay. So you're looking at this and you're saying, okay, negative 3, 2. Okay. Negative 4 comma 3 looks like this. I know that I'm not going to be going this way at all, right? So maybe you're thinking, well, do I go this way? Is this my graph, okay? So if it is, well, it is. I can say that. It is the graph. But what are the transformations that have happened? Okay. So what has happened here, okay? So we notice that minus 3, which is inside the radical, right? So what we want to do is we want to compare it, right? And see what has happened, right? X minus h plus k. Okay. So if you look at this, we can conclude that the value of h is a positive 3, right? The value of k is a positive 2. So we're going to shift this to the right 2 units, or right 3 units, and shift this up 2, right? But then wait a minute, what about this negative? What about this negative that x is being multiplied by? And what is the role of this negative here, right? And what this negative does, it's going to reflect the graph across the y-axis, okay? But then the question is, okay, does the order matter? Right? And the answer is yes. Okay, very important. We always do the horizontal shifting first. Okay, so we always do the horizontal shifting first. We always do the vertical shifting last, right? So the reflection should go second in this case. Okay. So remember, horizontal shift is always first. Always, always, always first. Okay. Vertical shift. Any vertical shift that happens is always going to be last, okay? So any reflections and any stretching, we can do that in the middle. That order doesn't really matter. But you always have to do the horizontal shifting first and the vertical shifting last, okay? Let's take a look. Well, wait a minute. Okay, if I take this point and I shift it to the right 3 units, we end up over here, right? So I'm going to shift it to the right 3 units. So this point gets shifted to the right 3 units. But wait a minute. I'm going to reflect this across the y-axis. What does that mean if I reflect this across the y-axis, right? The y-axis acts as a mirror. So if you sort of fold this across the y-axis, this point actually folds over and goes here. Okay? So it goes from positive 3 to negative 3. And then what's the last thing that happens? We're going to shift this up 2 units, right? So we're going to go up 2. Take a look at this point, right? The point 1, 1. I'm going to shift it to the right 3 units. Okay? I'm going to shift it to the right 3 units. But then when I reflect it across the y-axis, right? It folds over across the y-axis and comes over here, right? And then lastly, I shift it up 2 units. Okay? So yeah, this is the correct graph. Okay? Remember, you can always plot points to sort of get a better idea of what the graph is doing, right? But using transformations, right, we were able to get the same exact thing. So what has happened to the graph of radical x? We shifted everything to the right 3 units. We reflected everything across the y-axis, so the y-axis acts as a mirror, right? So everything folds over, and then we shifted it up 2 units. So this would be the final graph.